All right, I really like this topic because it's a thing that's really applicable. Where did my pictures go? I was going to show you some pictures of these. So what we're going to, you have to have an imagination for this. What we're going to actually draw on the paper is like the base of the shape. You have to imagine shapes popping up out of the paper towards you. Like, do you remember when you were a kid and you had those pop-up books? Like you would open it, stuff comes up out of the paper. You have to like imagine that. Here's what they would look like if we could actually like draw the whole thing. This is going to have a circular base. Do you see how the triangles are coming up out of the paper? We're going to find the volume of stuff like that. Here's another one, has a circular base, and there are rectangles coming up out of the paper. We're going to find the volume of that. This is how 3D printers work. Do you know how they print like a slice at a time? What we're doing is adding up all of those slices. That's what an integral does. It's going to add up all of those slices, and then you find the volume. That's cool. That's so cool. It's just cool how that works in real life, okay? But you have to imagine this because it's not going to be drawn on the paper. You have to have an imagination, okay? Like last time with the areas, if you are perpendicular to the x-axis, it's dx. If you are perpendicular to the y-axis, it's dy. The nice thing about these is they come right out and tell you. It's going to be stated in the problem which one it is, so you can't mess it up. Unlike the areas where you kind of just had to look at it and see, is it right side up or is it sideways? These ones are going to tell you. All right, so let's graph the base of the shape. Bounded by, all right, what is this graph going to look like? It's a squared, so what does that mean? It'll be a U shape. Good. All right, let's plug in some numbers. If we plug in 0 for x, what are we going to get? We need to plot some points. So if you plug in 0, what do you get? 1. Good. 0, 1. If you plug in 1 for x, what do you get? Be 3/4. And same point on the other side because it's going to be a parabola. So 3/4, like as close as you can get it to that. And if you plug in 2, what are you going to get? 0. Good. So your parabola is going to look kind of like this. And then it says, and the x-axis and the y-axis. So look, you either have this area right here or this area right here. Does it make a difference? No, they're the same. So if you have a choice, pick the positive one because life is just going to be easier. We're going to use this as the base of this three-dimensional object. So again, you have to use your imagination. This is just the flat base of it. What are the shapes that are popping up out of the paper towards us? Squares. Here's what and perpendicular to what? What does it say? X-axis. What you have to imagine is there are all of these squares going this way, like a loaf of bread. Imagine a loaf of bread. These squares are coming towards you like this, okay? And what I always do is I say, we're gonna like pluck one of those squares out and set it aside so that we can label some stuff on it. So draw your shape, draw a square over here. I can't draw a square apparently. And the base of our square is this distance right here. Are you seeing that? Good. You have to have an imagination because you really can't see it. But like imagine this square coming up out of the paper. This is the base of the square. So this part matches up with the base of the square is that distance. So it is upper graph minus lower graph, the same as what you did with the areas. Upper graph minus lower graph. So what's the upper graph? Yeah, like that function. And the lower graph is the axis, that's 0. So you can write like minus 0, I suppose, but you don't have to. So we've got our shape labeled. Now we're ready to set up the integral, okay? What would be your boundaries? We want x's because it's going to be a dx problem. So from where to where? 0 to 2. Dx at the end. And what goes inside there is the area of the shape. So how do you do an area of a square? How would I get the area of a square? Yeah, it's the base times height, right? But it would just be, they'd be the same. I'm actually going to write it twice because we are going to have to multiply this together. You can write squared if you want, but we're going to have to multiply that. We're going to do some algebra, guys. So this is a bunch of distributing. 1 times 1. 1. Outsides would give you minus a fourth x squared. The insides would give you minus a fourth x squared. So what is minus a fourth and minus a fourth? Minus a half x squared. And then when you multiply these, negatives are going to cancel. Fourth times a fourth would be a 16th. And then it would be x to the what? Fourth. Good. Antiderivative, upper boundary minus lower boundary, and that's your answer. So what's our antiderivative for this? What would be your antiderivative of just 1? X. It's hard because you guys know derivatives and antiderivatives, and you really have to switch gears in your head. Like, it's hard, all right? Minus, now this would be 1/3 x cubed, but there's already a half there. So good, 1/6 x cubed, fun with fractions there. Now this would be 1/5 x to the 5th, but there's already a 1/16 there. So you got to do 1/16 times 1/5 is it 80th? X to the 5th, such that 0 to 2. Now it's upper boundary minus lower boundary, but you really don't need to worry about 0. So basically we're just going to plug in 2, and I would just be leaving it alone at that point. So draw your shape off to the side, and the base of your shape is either going to be upper minus lower, or if it's a dy problem, it'll be right minus left. It's either upper minus lower or right minus left. And these problems come right out and tell you which one it is. So that's the kind of nice thing about them. Let's try another one. The base of a solid is the region bounded by one arch of sine of x. Can we relabel the x? Oh, I'm sorry. Did I move it too quickly? Oh, I'm sorry. Copy error. I apologize. It was plus, wasn't it?
Yeah, I have plus.
Yeah, plus. Okay. I'm sorry.
My plus is under.
How can you mess up a plus?
Well, I don't pick up.
That's what, oh, so it looks like a fish.
Yeah.
Oh, okay. Got it. We're going to need to relabel the x-axis. I apologize. If we're going to graph a trig function, these need to be counting by pi over 2. So I'm sorry. If you could just change that to pi over 2 and pi, and then like going negative, it would be negative pi over 2, negative pi. So sine of x. Oh, we just talked about this in the warm-up. Where does sine start? It's going to be a wave 0. Good. So start at 0, and then it's going to wave like this. I did not draw that very well. Got a little bit nicer. So we want one arch of this and the x-axis. So this part right here is the base of this 3-dimensional thing that you have to imagine, right? So you have to imagine shapes popping up out of the paper. It's going to tell you the shape, and it's going to tell you perpendicular to whatever. So just read through, what kind of a shape have we got? Good. X-axis means they're going this way. It's going to be a dx problem. So you have an infinite number of these triangles. This would look like this one. Triangles popping up out of the paper. And what does equilateral mean? Everything's the same. All the angles are the same. All the sides are the same. So draw yourself an equilateral triangle, you know, as good as you can. I'm not grading your art skills here. And the base of it is going to be upper graph minus lower graph, just like with the areas. So what is going to be the base of our triangle? It actually is b sine of x, right? Because the axis is 0. So the base of this is just sine of x. So when we go to set up the integral, we want x values for the boundaries. So it would be from where to where? 0 to pi, but dx at the end. And what goes in there is the area of the shape. So how do you do an area of a triangle? Good. 1/2. Base is sine of x. We're missing the height. So it's 1/2 base times height. The base is sine. We need to find this height. which as a heads up, that's gonna be like a little bit of work, okay? But I believe in you. If this side is sine and all the sides are the same, that means this side is also sine of x. With me so far? Okay.
we're gonna have to do that.
We are gonna do the Pythagorean theorem, okay? But hold on, you're like, I think a little bit ahead of me. If we look just at this triangle, what is this part worth?
1/2.
1/2 sine. And then I'm gonna call that h for height. So if you do Pythagorean theorem, it'll be h squared plus
That's fine.
1/2 sine squared equals sine squared. All right, and then you're gonna have to fight your way through it, but it's not gonna be that bad. 1/2 squared would be 1/4. And that's really all I did on that step. I just squared that. Now that looks like a big jumble. So remember what your goal is. You're trying to find h. You want h by itself. So what would you do with this? Minus. So 1 sine squared minus 1/4 sine squared. 1 minus 1/4 be 3/4 sine squared. And then what's your last step? Square root. So square root of 3 is just square root of 3. You can't do anything with that. Square root of 4,
We're gonna do
2. And then square root of sine squared
so,
would just be sine. Did you guys notice how it came out to square root of 3 over 2?
yeah,
Does that remind you of the unit circle? You know that the unit circle comes from the Pythagorean theorem. Okay,
it does.
just check.
The one we thought.
That's where all your triangles are like come from. Anyway, you would put that in the calculator. We're not doing that by hand, okay? So make sure you are in radian mode. The mode only really matters if you're doing trig, but we're doing trig here. So make sure you're in the correct mode or it will not turn out right. So math 9, you want to do 0 to pi. Do you guys know where pi is on here?
Yeah.
It's the exponent key. You just have to hit second. You get it? All right, I'm just checking to make sure everybody's got it. I hate the button pushing. I'm not even going to try to conceal that from you. If you type one thing wrong, it's wrong. What'd you get? No one wants to share? You want me to hit enter first? Okay, good. All right, let's go ahead and graph this next one. Base of a solid is the region bounded by. All right, that's your cubic graph moved up 1. So you're going to go up 1, put a point. And then what are some other points you can put? You can either just know sort of what shape that is, or you can plug in numbers and see what you get. But what's another point we can put on this graph? -1, 0, good. 1, 2. And it's going to be like a wiggly kind of thing. Y equals 0 would just be the x-axis. That's just this here. And then x equals 1, vertical line at 1. So this is our shape. It looks sort of like half of a Hershey Kiss. And then they come right out and tell you in these problems, which is really nice. The shape and whether it's dy or dx, perpendicular to x or perpendicular to y. So read through. What kind of a shape do we have? Rectangles are great. They're easy to deal with. Triangles are the hardest ones. Rectangles are easy. We can do that. All right. And then perpendicular to, oh my gosh. Okay. They're sideways this time. Well, you got to read. As soon as you realize it's a dy problem, you have to go back and rearrange this equation. You have to make a full commitment to the entire thing being backwards. So I'm just gonna write in the margin here, what would you do to rearrange this equation? You gotta make it the other way. It's -1. And then cube root, perfect. Okay, good. I'm glad that sounds like that went okay, because I don't want that to be the part where like struggling over. And again, I've found over the years, and I don't know why, but if you circle that, that helps for some reason. Like when we go to fill in the integral, if we circle that, everyone like remembers it for some reason. It just helps, right? So here's your rectangle. And the base of it, instead of upper graph minus lower graph, this time it's going to be right graph minus left graph. And I've also found, for whatever reason, labeling that helps everybody too. So what's our right graph? Yeah, just 1, right? Minus the left graph is that stuff. And again, if you circle it, that helps. All right, now we're ready to set up the integral. You need y values for your boundaries because it's a dy problem. So look at your y-axis. It'll be from where to where? Zero to 2. Good. dy goes at the end. And inside there, you put the area of your shape. So how do you get an area of a rectangle? Good. Base times height, side times side, one side times the other. All right. So this is the base. What's the height? If you go back and read, they actually do tell you 2 times the width. So your height is 2 times this stuff. So your height is double what the base is. So when you go to write that in here, if you do this stuff times this stuff, the shorter way to write it would be 2 times all of that mess squared, because it's times itself. I'm just trying to save you some writing. And we will be putting that in the calculator. We are not working that out by hand. Now, when you type it in the calculator, still use X. The calculator will never know. It'll be our little secret. Okay, you have an X button, so it's just more convenient. All right, so go ahead and type it in. Use your X key. Just because you don't want to hit alpha Y every single time. And do you guys know where the cube root is? In good math. If you can't find where something is, try math, because that's likely where it is. Mine's thinking. Did yours have to think for a minute?
Yeah, mine's not
You're sunk for a little bit. 6.4? I think if you do work it out by hand, you get exactly 6.4. Like that's a perfect answer, but we'll put 6.400 just to like be super thorough. I'm gonna keep going because I want to, like, I would normally do a brain break, but I want to like get to play a game. We never do anything fun in here because the notes always take the whole time. So I want to keep going. We can finish these last 2 and then we can actually like do something else. All right, base of a solid is the region inside the circle x squared plus y squared equals 4. You haven't graphed circles since geometry, which what was that, like 4 years ago at this point? So I will remind you, if you square root this number, that's your radius. So what's the radius of this circle? 2, okay? So it's centered at the origin, and you would just go 2 each direction, and here's your circle. Actually drew a pretty good circle that time. Usually they just look like a squashed orange because it's like very hard to draw like a nice circle.
my circle's pretty bad.
Mine actually turned out pretty good today. Good. All right, so it's going to tell you the shape and it's going to tell you perpendicular to whatever. This is just the base. Remember, there's shapes popping up out of the paper at us. So what shape have we got? Triangles are the hard ones. So this will be a little bit of a harder problem. Okay, so triangles and perpendicular to
Next.
x-axis. So all your slices are going this way. Now there is a lot of vocabulary in this one, which is cool. We'll get to talk about the vocabulary. What does isosceles mean? Two of the sides are the same. Right triangle means has a right angle. And it says the hypotenuse is the base of it. So this is going to be the hypotenuse. And then when you draw your triangle, these are the two sides that are the same. All right, isosceles means two of them are the same. So actually, what are the angles? Do you know what kind of triangle? It's a 45, 45, 90 because two of the sides are the same. So as a heads up, this one's going to be a little bit harder. Triangles are tricky, okay? We're going to get through it. Now, the base of it is going to be upper graph minus lower graph. So you're going to have to come with me on this. The upper graph is this semicircle. The lower graph is this semicircle. You have to rearrange this equation so that it's y equals. Now, you guys are good at the algebra. How would we get y by itself here? Minus x squared. And then square root. The top part is the positive square root. The bottom part is the negative square root. That's the plus and minus. So when you write that over here, upper graph minus lower graph, let me take you through this verbally to try and save you from having to do a whole lot more writing. If you come with me on this thought journey, I won't make you write it out. If you do this minus this, so you have this square root minus negative square root, what is going to happen? Good. Why are there two of them? Minusing and negative, which means adding. So you would have two of those square roots. So this base is 2 square root 4. Good. I didn't want to have to make you write all that out. So if we just kind of thunk our way through it, then you wouldn't have to write it. All right, now we're ready to set up our integral. You want x values because it's a dx problem. So look at your x. You actually kind of can't mess this one up because it's a circle. So it's the same both ways, but it would be from where to where? Yep, -2 to 2. Dx goes at the end. You put the area of the shape in there. So area of a triangle. Good. So 1/2, here's our base. And we, again, don't have the height. We are missing the height. But again, if you kind of come with me on this thought journey, we won't have to write a whole lot out. Here's the height. Maybe just watch me point to this. If the whole way across is 2 of those square roots, what is just this part? 1 of them. And do you see how the height is going to be the same? Because, okay, so the height is just 1 of those square roots. Now we are going to actually do this one by hand. I know it looks a little scary, but some stuff is going to cancel. Integral -2 to 2, and what's going to cancel in there?
Oh, yeah, the 1/2
The 1/2 and the 2 go away, so that's nice. And when you have a square root times a square root,
goes away.
it goes away. So it's just 4 minus x squared. So after all of that, you end up with something that's actually not too terrible. Antiderivative, upper boundary minus lower boundary. So what's our antiderivative? Beautiful. Such that -2 to 2. So if you plug in 2, that'll be 8 minus 8/3. Good. And if you plug in -2, it'll be -8 plus 8/3. You could go through that and like combine some of that stuff together, but I think for the sake of time here, we'll just leave it. Last one. Yay. All right, so let's graph these. 1 minus x squared. It's going to be a parabola. It's going to be upside down. And it's going to be, what direction moves? Up 1, good. So we're gonna go up 1, put a point. And then I need like a couple more points.
Zero, 1, 0.
1, 0. And so also -1, 0. And then if you plug in 2, -3, perfect. This one is actually also going to be a parabola. Like to the 4th just makes a little bit of a narrower parabola, and it's going to be moved down 1. So you're going to start here, down 1, and it's going to do something like this. So this is the base of our shape. Looks like a cartoon mouth or something. So you have to read through. It's going to tell you 2 things: what shape and perpendicular to what axis. It's nice, these ones tell you exactly what it is. So what kind of shape do we have? Not a whole circle though, semicircle. And perpendicular to what? Good. I like when it's x-axis, like a little bit more straightforward. So the base of this is going to be what? How do we get that? How do we get the base of our shape? And I wouldn't call them boundaries, it's like the graph, but like the upper graph minus the lower graph. All right, so which one is the upper one? All right, good. So 1 minus x squared minus the other one. I would like distribute the negative and kind of combine some stuff together there, just because you're gonna have to recopy that into the integral. So let's do that. 1 minus x squared, it'll be minus x to the 4th plus 1. And then you can put the 1s together. I would just take a couple seconds and do that, because then when you go to recopy it, it's not as bad. All right, integral from where to where? We want x's because it's going to be a dx problem. -1 to 1, dx at the end. What goes in there? How do you do an area of a semicircle? 1/2 pi r squared. Perfect. And I'm a big fan of always doing everything blank and then going back and filling it in. Here's the most commonly missed thing on this. It's 1/2 pi r squared. This isn't r. What is, it's the diameter. It's the whole way across. So what do you have to do to this to make it be the radius? 1/2 of it. And I think the easiest way to write that is just to put it over 2. That's the most commonly missed thing though. People will just take that and put it in there. And I get why that happens, but this is the diameter and you want it to be the radius. We will not be working that out by hand, so go ahead and type that one in.